Okay, guys, I'm going to try my best to give you a little tutorial on factoring numbers using factor trees and prime factorization, and ultimately to get all the factor pairs using a factor rainbow. Now, the big question is, what the heck is a factor, right? So factor is any number that can evenly divide into a larger number. Okay, another way of describing it might be a number that can be multiplied by another number to equal a bigger number. All right, and I know this sounds confusing. It always does when we use words to describe it, but once you see the actual mathematics play out, it'll start to make sense. And you've probably seen something like this before. So what we're going to do today is we're going to practice using this template here. I know you don't have this at home, but you can make something very similar to this, and I'm going to show you each of the stages that you need to do to complete this, all right? So the first thing we're going to do is just pick the number that we want to start with, which is going to be 18. Why 18? Well, it's got a few factors we can work with. There's several numbers that can divide evenly into 18, but it's only two digits. It's not too big, so it's manageable. So the first step that we always follow is to complete the factored tree. All right. Now, in order to complete a factored tree, there's a couple things that you need to know. Number one would be which numbers are prime numbers and which are composite. You can refer to the other resources posted on Classroom to see the difference there. But basically, a prime number is a number that has only two factors, one and itself. No other numbers can be divided evenly into a prime number. And that makes them special because when we do a factored tree, we want to break these numbers down. And once you hit a prime number, you circle it and the tree ends. You can't go any further. And we collect all the primes and go from there. All right? That's a lot to take in right now. I understand that, but we'll just take it slowly. So starting here, you're going to begin your factor tree by putting the number that you're working with right at the top of the tree. Okay, so next you see two branches coming off of here. So what that means is we need to start with two factors, any two numbers that when multiplied together will equal 18. So my first recommendation would be to check, first things first, is this an even number? Yes, it is. It ends with an 8, which is an even number. So any number that ends with 0, 2, 4, 6, or 8 is an even number. And we know that that can be divided by 2. So the first number I'm going to add to the factored tree is 2. Well, this is cool because if you look at your factored tree, your list of prime factors, you'll see that the number 2 is a prime number. So we're going to circle that. And that means that on this factored tree, we don't need to go any further. It stops there where we have the circle. Simplifies things. On this side, though, we have to figure out what number we would multiply 2 by to equal 18. Okay, we've started with a nice small number, and hopefully you know enough straight up multiplication facts to know that 2 times 9 is 18. So I'm going to put a 9 right here. Okay, you can use a multiplication chart if you're digging for factors. Sometimes that's a really nice way to do it. But for right now, we're going to just do it this way. 2 times 9 is 18. I know that this is a prime number, and that's why it's circled, and I'm not going to go any further with that particular number. But 9 can definitely be broken down further. So the number 9, what numbers can I multiply together to equal 9? 1 times 9 works, but we don't use 1 in a factored tree because it's just a given. Every number can be divided by 1, so we don't even bother with that. But I do know that 9 can be broken down into 3 times 3. Okay? Now, here's where the magic happens. We know that 3 is also a prime number if we look at our list of prime numbers. So I'm going to circle both of those 3's. And we're just going to stop right there.